All these are fasteners. If we were carpenters, installation would be a simple matter of driving nails and snugging screws. But our fasteners are a different story. Our assemblies are critical and more complex, and for that reason, we must have much greater knowledge of fastener installation.
This is the first of 5 videos on fasteners and torque.
You will learn more than you thought there was to know about these subjects, but that doesn't mean that you can do without references and manuals. Let's look at the topics we'll cover. This first cassette will present the very basic concepts, laying the groundwork for areas we'll look at later in a bit of detail. Video 2 will focus on fasteners. There are thousands of variations. We'll look at fastener basics, assembly drawings, and torque callouts. In video 3, we see why torque values reflect measurements of force and distance, and how to change units of one size to another. Video 4 surveys the characteristics and handling of torque wrenches, and reviews some important assembly techniques. Video 5 illustrates wrench extensions, their effect on torque values, and correction calculations. Tension is what it's all about when it comes to fasteners and torque. Just the right amount of tension. Let's look at how a fastener works, and then we'll have a look at what we can do to make it work right. If we have selected a fastener that fits and is strong enough for the loads it will encounter, why is the torque we install it with so important? A simple fastener everyone uses can illustrate our basic principle. As the band is stretched, it creates tension. And tension is what we use for fastening. It can't be seen, of course, but a metal fastener is to a small degree elastic and can be stretched in the same way when we install it. With a typical installation, the torque value specified stretches the fastener to about 70% of its elastic limit. While stretched, the fastener tries to maintain its original size. This internal tension is the clamping force that holds the assembly together. The more tension produced, the greater the clamping force. Most of the torque force that installs a fastener is used overcoming friction. 35 to 45% with thread friction, 45 to 55% with head or nut friction. Only 10 to 20% of applied force creates fastener tension and clamping force. But when we specify torque force, we specify clamping force. The tension or clamping force specified for a fastener is often referred to as preload. If an assembly is to function properly, fastener clamping force or preload must be sufficiently greater than outside forces, so that the fastener and fastened components function as a single, solid unit, even when subjected to loading. The unit then functions as it was designed to, with safety and reliability. But if clamping force is less than the load force applied to the assembly, the fastener is further stretched each time it is subjected to such a load, and relaxed when it is removed. This stress-relax cycle is very rapid with the vibration associated with most machinery and all flight hardware assemblies. The eventual result of the stress-relax action permitted by too little clamping force is fastener loosening or metal fatigue. Too much tension also brings failure. It takes the fastener material too near its elastic limit and leaves it without a safety margin. Too much tension also reduces resistance to shear stress. If failure results from both too little tension and from too much tension, then we must measure tension and clamping force when we install. How shall we do that? Let's get back to our two fasteners. When we stretch them, they produce clamping force. We have no need to measure the tension of a rubber band, but if we did, it would be easy to measure it directly. With heavy, expensive equipment in a test laboratory, we could stretch this fastener and take a direct measurement of its internal tension. Obviously, this is hardly an option in an assembly situation. But our fasteners do require a specific clamping force. Fortunately, our installation tools, used correctly, give us a very accurate measurement of clamping force. Here's what's involved. The threads of the turning fastener will act as a load advanced upon an inclined plane, the threads of the receiving member. Stretching and tension begin after the bearing surface fully seats. The stretching created by continued rotation or torquing of the fastener is proportional to the force turning the fastener. So we can measure clamping force by measuring installation force with a torque wrench. Clamping force is also proportional to the degrees of rotation that the torquing force produces. This reflects the distance the load is carried on the inclined planes of the threads. This distance we can measure easily with an angle gauge. Angle gauges are increasingly used for very precise final measurements. We'll have more to say about angle gauges, but our focus this time is on torque wrenches. Torque is measured at the axis of the fastener. Torque applied at a distance from the axis is multiplied by that distance, making wrench selection, calibration, and handling critical. Torque wrenches do a job that's pretty simple, but not one that can be accomplished without knowledge and total attention to the work. These are more than ordinary tools. They are precision measurement instruments. Torque wrenches vary. We must know which is the right wrench and why it is the right wrench. We've covered the what and why of fastener tension and torque value and measurement. Before we move to the next cassette, let's have a short review. Fastened assemblies must respond to stress as a single unit. Rotating threads act as inclined planes to stretch the fastener, producing internal tension, the clamping force that holds the assembly together. Internal tension or clamping force is accurately measured by measuring the torque or turning force required to produce it. Torque is measured at the axis of the fastener. Force applied at a distance is multiplied by the distance from the axis. Because wrench length multiplies force, both wrench selection and wrench handling are critical. These videos cannot take the place of hands-on training, nor will they eliminate the need for reference to procedures and tables. They will give an understanding that will make learning stick. Torque values are part of engineering design. For technicians with test and assembly responsibilities, knowledge and skill with torquing fasteners is an important part of an important job.